All right, well, let's get started here. Again, Mo's here to talk to us regarding building stable, resilient applications. And so without further ado, I'll let Mo take it away. Mo?
Hello, hello. Perfect. Right. Thank you. Yeah. Thank you so much. Yeah. Hello, everyone. My name is Mohammed Nufal. I work as an application modernization architect in the global black belt team in Microsoft. I'm based out of Luxembourg, and I do cover Europe, Middle East, and Africa from there. This is 6 years in Microsoft. Before that, 4 years in Amazon Web Services, doing more or less the same. And before that, mostly in the telecommunication industry. So today we're going to talk about how can you build resilient stateful applications in Kubernetes and in AKS specifically. So we're going to go through what do we offer as managed Kubernetes offering in Azure. And then we're going to go through, okay, how can we build a resiliency in the stateful application itself, and how can we protect that stateful application from any anticipated failure. Right. So in terms of managed Kubernetes offering today in Azure, we do have 3 managed offerings. We have Azure Kubernetes Service, we have Azure Red Hat OpenShift, and we have Azure Container Apps. Azure Kubernetes Service and Azure Red Hat OpenShift, they offer you full access to the API server, right? Where Azure Container Apps abstracts the API server, and it's like more of a PaaS service, right? Our focus for today will be AKS and Azure Red Hat OpenShift, because anything that fits in AKS will fit for Azure Red Hat OpenShift too. Right. So what is a stateful application? A stateful application is an application that stores the data from one session, so it can be used from the next session, right? So we're talking about, like, in the SQL world, things like SQL or MySQL or Postgres and so on. In the NoSQL world, we're taking things like Cassandra, Kafka, Elasticsearch, and so on. And then, of course, you have the CMSs like WordPress, and then in-memory databases like Redis, and so on. All of these, they are considered stateful applications. Right. Now, you may be wondering, why would you build a stateful application in Kubernetes, right? Given that you are in the cloud already. And then there are like 3-4 things that customers think about, like when building stateful applications on their own, right? The first one is there is no managed offering to use in Azure, for instance, for your stateful application. For instance, we don't have an Elasticsearch managed service, so you're going to build something on your own in Azure, right? Or you're lifting and shifting something from your on-premises to the cloud. You need to move fast. You need to, the path doesn't fit your requirements, so you're going to do lift and shift into the either Kubernetes or a VM. You require more control, right? So the path is normally restrictive, so you're going to be requiring more control over your stateful application. As such, you're going to build it on your own, right? But the thing is, like, once you decide to build things on your own, then you just made a decision to have more control, which means that this is more operational overhead on you, right? As such, we need to think more of how can we protect our applications, right? So now, if we are to build stateful applications in Azure Kubernetes Service, there are different set of storage offering that we offer so you can use for your different workloads. The first one is Azure Disk, and Azure Disk is a block storage, right? So anything that fits for a block storage, databases and distributed databases, that's a good use case for block storage, right? And then in Azure Disk, you have different types of SKUs, like standard HDD, that's magnetic disk. You have SSDs and so on, right? And then we have Azure File. Azure File, this is a shared storage, right? Like shared file storage. So anything that is fit for file storage, like shared workspaces and so on, this is where Azure File fits in. And then we have Azure Blob and Data Lake Storage. This is where you're going to use Blob Fuse or NFS to mount them. And this is for HPC use cases, Data Lake use cases, and so on. And lastly, we have Azure NetApp Files, and that's also a file storage, but it's like more tiered towards things like HPC workloads and so on. So all of these options are available for you whenever you decide to build a stateful application in Azure Kubernetes Service. Right. So when we say resiliency, what do we mean by resiliency, right? Resiliency, as defined by David Woods and the 4 concepts of resiliency, He built the resiliency concepts for aerodynamics and airplanes and so on. And then that got into computer science for everything that is resilient, right? And then that's also inspired by Sam Newman and building microservices. So we have 4 different concepts for resiliency. The first one is robustness. Robustness means how can I protect myself from things that I know will happen, right? So you are in Azure. A availability zone could fail, right? So how can I protect myself from an availability zone failure, right? I'm going to build multi-easy service. So that's robustness, protecting from things we know will happen, right? Now, there is the rebound. Okay, something bad happened. We failed. How can we rebound from a traumatic event? How can we rebound from something that happened already? And then we have graceful extensibility and sustained adaptability. These are like more people-focused and process-focused. We're not going to talk about these today. We're going to focus only on robustness and rebound. All right. Also, there is something that I have been using for the past years. I call it the Resiliency Ladder, right? And how you can think of resiliency while building your services. So in the cloud, the first thing you do, for instance, you start with a single availability zone, right? That's the least possible availability that you can get. You can auto-scale it, you can do whatever, but then you cannot get over 3 nines of availability, right? The second thing that you should do is to think of backup and restore. Regardless, like if you're here, if you're there, if you're down, you should always have backup and restore. Because if things failed, I need to be able to restore, right? So that's backup and restore. Then you're going to use availability zones, right? I need to move from having 3 nines to 3 nines 5. Availability zones will give you that, right? Then you're going to maybe have multiple clusters within a region. And then the last thing down there is multiple clusters across regions, right? This is where we think like, many nines. Now, as you go down, right, you're going to get higher complexity and cost, obviously, right? As you go, up, then you're going to get the highest RTO and RPO. Highest RTO, RPO is a bad thing. So we need to go down to get the lowest RTO and RPO, right? So this is how we think of it. This is how you should think of it. And then as you're building like your stateful applications and any resilient application in general. Right. So I'm going to walk you through an example, right, today. And our example is going to be Elasticsearch. We're using Elasticsearch because it has like this complex architecture, and there's a lot of moving parts. So it's a good example to use to show like the resiliency in Kubernetes with Kasten, with a complex application. So for those who don't know how Elasticsearch works, we have 3-tier architecture. We have the client. This is your reverse proxy. So if you're asking for an index, that's where the call will go, and then it's just going to pass the call to the backends. We have the data. The data is where your indices are, right? This is my actual data. And then I have the masters. The masters is like, okay, where each index is, where each chart is, and so on. So that's the architecture in general. Data is persistence. Master, you can have persistence. Clients, there is no persistence. That's stateless. Okay. So let's start by robustness. When we talk about robustness, like this is how we designed that cluster to be robust. So I'm going to install Elasticsearch in an AKS cluster. I want to make it robust, and then I'm going to be able also to design for rebound as well. The first thing that we did is we have 3 dedicated node pools spread across 3 different availability zones. So now we have 3 nines 5 in there. Each shard in Elasticsearch will get a 3-way replicated. So we're going to make sure that the shards are replicated as well. We're going to have a dedicated storage class. In AKS, we provide you with storage classes by default. But if you have a critical application like Elasticsearch, probably you're going to use your own storage class because you have your own parameters in there. Each Elasticsearch node is tainted because the Elasticsearch nodes that we have, they have high storage requirements, high memory requirements, high CPU requirements. So probably I'm not going to share Elasticsearch nodes with some other applications because this is expensive nodes comparing to less stateful applications like that do not require that compute power. And then we're enabling auto-scaling. Our cluster in general will look something like this, right? So we are within an Azure region. In the Azure region, I'm using 3 availability zones. In each availability zone, I have a node pool, 2 free. And then in the Elasticsearch itself, I have coordinating is the client. So 2 pods for the 6 pods for the clients, 6 pods for the data, and then 3 pods for the masters, right? I'll show you like how this work. Whatever I'm talking about now is in this repository, so you can follow along. You can just do it on your own, right? The slides are also in that same repository. So creating the cluster itself is pretty straightforward. There is nothing really out of the ordinary for it. So I'm creating a resource group, if you know Azure. I'm creating an identity, creating a virtual network so we can host the cluster in that network. Assigning permissions for the identities and so on. Again, this is not how it should be in production. Just relaxing things a bit just for the demo. So you cannot just go and then in production have a an identity that has subscription access. That's really bad. Right. Then I created the cluster. It's straightforward as AKS create and then the rest, right? Well, I'm just doing some validation there, and then I'm just adding the 3 node pools, right? Each node pool is tainted, and it has between 2 to 4 nodes, and auto-scaling is enabled, and each one is dedicated to a zone, right? 1, 2, and then down there is 3. Elasticsearch itself, right? This is how it's going to look like. I'm not going to walk you through the whole setup, but I have the Helm values file in there, so you can just use it for this exact setup. Right? So I'm creating the storage class, and then I'm just modifying some parameters in the values file for the Helm chart, right? This is the important bit, right? That's how we make sure that our pods are spread across zones, and we're making sure that we have exactly the same spread across all the zones that we have, right? So that's the affinity bit of it. And then I'm tolerating as well. Why I'm doing taints and tolerations? Because I don't need other apps to end up in the same cluster. Then I just go and deploy the Elasticsearch. This is straightforward things, just deploying the Helm chart. I'm doing some validations for the Elasticsearch. Where is the important bit? There, right? Now, after validating that Elasticsearch is working, I went and just added an index for a customer. Each index has 3 shards and 1 replica, right? Then I just went and validated that this is working. So how we handle failure in this mode, right? So I'm doing this in video because this is lengthy. But if you wanna follow along, these are the commands that you're gonna do. Come on. I don't know. I don't know. It's not working. Anyway, what I'm doing in general, right? I'm checking the customer index constantly with a while loop, right? Then on the other end, I'm going to be deleting pods where the shard is, right? I'm going to be keep watching this, and then AKS in the back end, what it will do is, technically, whenever I delete a pod, the pod will get recreated, but given that I have replica of the shards, the application will remain working. So even if I deleted the zone, then my application is still working, right? So that's that demonstration. So you can, I'm not sure why it's not working on the screen, but that's demonstration is right there. Cool. So now we built robustness in our application. We have multi-node pools. We can tolerate 1 zone, 2 zone failures. We can tolerate pod failures. We can tolerate all of this, right? But bad things could still happen, right? Now we need to think of rebound. And rebound in general is, OK, so we built all that robustness, but still things could happen, right? Like there are human errors that we need to protect from, right? Somebody went and deleted the whole cluster. There are underlying issues that could happen, like from compute side, from AKS. There could be data corruption that happens, regional failures, and so on, right? Or we have maintenance. For instance, I have a cluster or no pool upgrade. I need to make sure while upgrading that, OK, I still have my data available. I need to test or migrate to a new version of Kubernetes, or I need to migrate my data from one region to a second region, right? So all of these things, I cannot do them with just robustness. This is rebound type of things, right? This is where Kasten fits in, right? So what Kasten will do for us, it does, when we install it, it's pretty straightforward. I'll show you that. It does auto application discovery. It shows me which applications are compliant or non-compliant. Compliant applications are the ones who are protected by backup. Non-compliant are not protected, right? And then for each of my applications, I can build policies so we can, protect these applications, right? So that's where Kasten will provide me with the rebound bit of things. Like assuming failure has happened, I can still restore my cluster to a good name state, which is the restore point that I did, right? Back to the demo. So installing Kasten itself, there are multiple ways. So obviously, Kasten would require an identity in Azure, right? There is the service principal way of doing things, and there is the managed identity, right? I use the service principal. In production, use managed identities. Don't use service principals. I'm doing a really bad practice in here, also assigning the identity wide permissions. That's also for just demo purposes. In your case, you're just going to assign the identity access to a storage account and a resource group. Cool. So what I did is I created service principal. That's where we started. And then now we created a snapshot class. That's just to tell Kasten, OK, there is a snapshot class for Kasten itself in AKS. Installing Kasten is done using a Helm chart. I'm providing some parameters. This is like pretty straightforward. I need logging, I need Grafana, I need so on, and then how I'm going to do the authentication and so on. OK. The important bits. So once we install Kasten, we need to decide where we're going to ship our backups, right? So for this, I created a storage account in Azure. That storage account is normal Azure storage account where you're going to ship your backups. So this is the creation of the storage account itself. I need to create a secret for that storage account so Kasten can use that secret to authenticate against that storage account. And then from there, anything that you can do. So Kasten has one of the prettiest UIs out there, like for a backup solution. I'm not using the UI. I'm using the CLI, the API, just, again, for demo purposes. But anything that you can do on the UI can do on the API and vice versa, right? So there I'm creating a storage location. A storage location is where I'm going to ship my backups. You can have multiple storage locations, but we just created the storage account, so we created a storage location for it. Then I'm going to create a backup policy. And the backup policy is technically how often I'm going to do backups for my applications. And then you can technically choose the affinity for that backup policy. So in my case, I'm choosing to backup anything that under the namespace of Elasticsearch, right? And then the last bit there, this is an action. So what I did is instead of waiting for an hour to do the backup, I just created an action and said, go do backup now, right? With this, now I have an Elasticsearch backup already stored in an Azure storage account using Kasten. And from there, I did the demonstration. So the demonstration is pretty similar to the last one. I'm watching the index itself. Then what I'm going to do is I'm going to delete the index from the cluster, so there is no longer a customer index. I'm just going to keep watching my my replicas and shards, what they're doing in the meanwhile. So now once I delete the index, I'm going to start seeing errors. These are the errors, right? So there is no index now, so I'm trying to get the index back. There is nothing, right? The third thing that I did is I went to the Kasten UI and created a restore action, so I can start restoring my application. And then lastly, when things go back to normal, the index will remain, like, will keep working, or get back to work, and then that's it, right? Worth mentioning other things. What I did there is deleting the index from one cluster only and restoring this. There are other scenarios, so I'm referencing another repo in there. There are other scenarios where you can restore in a different cluster. There are other scenarios where you restore in a different region as well. So all these options are available for you. So once you need to, like, your data from one region to the other, you can just do that. You can even migrate across clouds as well, right? So all these are available as well. And with that, that's all I have for you. If you have any questions, please go ahead.